everyone. Today we'll be discussing about a very interesting concept in mathematics, that is maximum and minimum. This is one of the very interesting applications of differential calculus. You are watching Mathematics Stream by an IITian, your mathematics bestie for school and competitive examinations. Now let us move on to our discussion. Now let us take the very interesting application of differential calculus, that is maximum and minimum. Okay, so this problem we can also call it as metro station problem. Okay, so what do you mean by this? Let us consider metro rail phase 3 corridor along this curve. So let us call this curve as y is equal to x square minus 3x plus 8. Now let's assume that there is one more highway here nearby this corridor which was planned, and the highway is along the straight line y is equal to 3x minus 5. Now the question is where to build a metro station in this corridor so that it is closest to this highway, and hence commuters can reach the highway in a shortest path. So the idea here is somewhere here, is it clear? So which means not every point is closest to the straight line, somewhere here it will be the closest. What is that? That's what we need to find out. Okay, now there is one very interesting concept here. So what you have to do here is assume that there is a curve like this, and if there is a straight line like this. Now if you want to find out a point on this curve which is closest to this line, what we are supposed to do is we have to find out a point on this curve such that at that point the tangent is parallel to this line. So when you are able to find out a point where the tangent is parallel to the line, that point is the closest. So if I call this as P and call this as M, PM is the shortest distance between this curve and the straight line. So let us try to understand what is the problem if I take any other point. Suppose if I take somewhere here, let's call this as Q. Suppose y, this is not the shortest. So it's very obvious. You can say that this distance is extra here, which means this is a rectangle, this is a rectangle, and this distance is extra. So anywhere you take, for example, if you take here, suppose if you take R, so which means this distance you have, so this distance is extra again because this is a rectangle. So anywhere else you take, you have extra distance, so PM is the shortest. So what we are supposed to do here is just find out a point, is it clear, such that the tangent is parallel to this line. So what we have to do is we have to just equate the slopes of this, and the slope of this line is y is equal to mx plus c. So m is 3, so slope of this is 3, and the slope of this curve is nothing but dy by dx. So dy by dx, which is nothing but what, 2x minus 3. So 2x minus 3 should be equal to this 3. So 2x is equal to 6. So x is equal to 3. So if x is 3, please substitute here. So what will you get? Y is equal to 3 square minus 3 into 3 plus 8. So this is nothing but 8. So therefore y is equal to 8 and x is equal to 3. So which means 3, 8 is a point where metro station is suggested so that it is closest to this highway. Is a point closest to the highway.